Can't you just see my oh, you don't see my face if you see okay, well, never mind. All right, so welcome everybody. Rholang office hours on Tuesday. This will be my first time hosting this,
Hi.
and so welcome Udo. Um, I found
Actually, I need to go to a call with Tim, but I'm listening.
okay, good. I found myself preparing this office hour just 2 hours ago, and I was making slides. It was not my intention, but I hope you appreciate that I'll just do these slides and walk over like the minimum things, and then afterwards there's I think a lot of room for talks, and any moment interrupt me if you have a question, and I would prefer to be just more like a talk and not me telling you something, but office hours like. Welcome, Gary. I just made a short introduction. I told everybody that I have some slides, which I'll go over now. I didn't mean to make the slides, but it just happened that I was making slides. So we'll go here, and now you're seeing, I believe, my slides, right? I don't see you anymore, so if you have anything to say, please just say something. Okay, that's today. Rholang office hours. You can find me on Discord via Acnear, which is my name written the other way around. If you wonder where the name comes from. I thought this will be a nice start of the program. So first we do a general introduction of the idea of these Tuesday office hours, at least what I think. We can decide on something else. Then primer and role fundamentals, we do a send, receive, and come event, and then in the end we talk a bit about persistent send and persistent receive. So since it's the first office hours, I thought to come up with an idea about what this office hours will be like. I think personally it would be good to have an entry level, which means no stupid questions at all, but it's also community led. So if the community decides it should not be entry level, but we should maybe go a bit more difficult, then that's also fine. But in principle, I think it's good to stick to entry level and see whom we can onboard more on Rholang. Any comments on this? Does it sound good?
Yeah, it looks very good, Rinka.
Okay.
I have a question. No stupid question. I don't really what's the word to use? Like I don't really understand what my no stupid questions. And I feel questions are relative to people. How people view it as stupid or not, I think is relative. So I don't know what you meant no stupid questions.
Yeah, it does sound like you're saying no stupid questions are allowed. You should say stupid questions welcome.
Oh yeah. I mean, there don't exist. There are no stupid questions, but I see. Okay, yeah, you got me there. Yeah, no, obviously, stupid questions are welcome, but they don't exist. So that's what I meant.
Okay.
Yeah. Okay. Yeah, and then here we think we got that suggestions. Let's just see where it leads us. My intention is to hold it every week, but if somebody else wants to step up, and if somebody feels we should talk about something else, more than welcome. Okay, so I thought let's start with a real primer on role fundamentals, which is names and processes. For somebody new to Rholang, this is confusing, I know from experience. And I thought just how I understand names and how I understand processes. So a name, for example, could be Amsterdam, which is my hometown. And then on Amsterdam, like many things are happening. Like you have tourism, trade, business, like you have living there, people do all kinds of stuff. But these are like things happening on a name. So from here, you see that a name and a process is always intertwined, right? The tourism always happens at a location, just as trade happens at a location. And a location, there's always things happening on a location. And the same is on Rome.
We're getting a little bit of echo there. I'm not
Yeah,
sure.
I think somebody is not muted. Okay, so I just told you very abstract idea about what's a process. But what does a process in Rholang look like? Well, it appears out that with a process you can do several things. Very basic, first like kind of ground process is do nothing. Then there is a process which is kind of listening, like you're listening on a name, and you see I put name in italics because you just as tourism, you always have something, a process on a name, just as listening, like you're listening on a name. And when you receive something, then do something. Whatever that do something is, we'll define later. The other thing is we can send on a name, and in Rholang we can do things concurrently, which means do them at the same time. And the other one, which doesn't have a very nice real life example, but it's like finding out at which name a process is. So for example, we look at the tourism, which is the process, and then we find out, okay, the name is actually Amsterdam. So that's what these are like processes in Rholang.
So is there a difference between a name?
Yeah, please continue.
I'm sorry. Is there a difference between a name and a channel?
No, a name and a channel is exactly the same. Yeah, good question. Because indeed, in if you're looking around in the documentation and everything, they call it a name, a channel. I don't know what kind of things, but it's the same. More questions here? Oh. Okay. And then, what is a name in Rholang, or indeed a channel? Well, very simply, a name or a channel is a location on which a process lives. Like a process must always be on a name, otherwise like you cannot do anything with it. And a name is just simply the location of this process. And then I'm sure you've all seen it, or if you're completely new, maybe you haven't seen it yet. But this is this kind of abstract mathematics-like notation of the row calculus. But actually, it turns out that it's not too difficult. What it says is just we have a processes, and we call them in an abstract way P and Q. And what are processes? Well, as I just told, we can do nothing, which is 0. We can listen on the channel, here channel Y, and after we receive something, we call it X, then do something. And this do something is P, which is a process in itself, so it's kind of recursive. We send the process P on a channel X. So here we're sending on channel X the process P, or name X for the matter. This one means do P and Q in parallel. This strange thingy here is what I said is dereference. It is like looking up from the name and get the process. That's what I said here. This one. Find out which name this process is. Oh, maybe I should find out which process this. Okay, never mind. Maybe this is 2 slides back wrongly told. And then here, X and Y, these are names. And what can we do with a name? We can quote it by putting the @ sign in front of it. And that's a name. So if you have a process and you put the @ sign in front of it, like you quote it, then you get a name. And I claim that this all is also told here and here, a bit more in not completely correct way. That's what math is for, but this is how I envision this, just for myself to explain it. And again, I'm not completely sure on the dereference, what I've wrote here. I believe here's a mistake, but somebody else can point it out.
The dereference is like an evaluation of X. I thought maybe you did that on purpose, but it's really the opposite of the ampersand.
Yeah.
Instead of
I'm sorry, what dereference are you talking about?
yeah, we don't see your cursor.
Wait, I can make a pointer. Yeah, great. Way here. So I wrote down here, find out which name this process is, but it should be find out which process this name is. As you see here, you dereference name and then you get a process. And here I just wrote it the other way around. So that's where I was confused about, but now I'm sure. So you can dereference a name to get a process, and you can quote a process to get a name. That's basically what it's saying here.
All right, so ampersand P quotes the process, turns process P into a name.
Exactly.
And star X turns the name X into a process.
Exactly. Yeah, thank you. That's completely correct. And also, I think what's beauty about this is that the names and the processes are completely intertwined in the Rholang language. Like you're saying, we have always processes, and processes, you can have to send them or receive them from a name usually. But what's more, you can kind of dereference or evaluate a name, and then you get a process, and you can also put a @ sign in front of a process to get a name. But I wouldn't like to stick too deep into here. Like, this is just how you define the row calculus mathematically, and I just want you to see it and to get an idea about what is possible, but it's not completely relevant for now to understand this completely. Although if you do, it's good, of course. Okay. Oh yeah, and today, as I said in the agenda, I would like to focus on sending, which is this one, and receiving, which is this one. Any suggestions for now, for questions? All good?
I have one thought
Yeah, sure. Go ahead.
about the last line down there where you have X, Y. Yes, you got to. Okay, so you put that ampersand in front of the P.
Yeah.
Which turned the process into a name. But
yeah,
what about the process? I mean, is that name bound to that process? In other words, if I remove the ampersand off of the P, I get the process back. But is that the process that is bound to the name that is the quoted process?
So you're asking? No, I don't think there's any binding here between names and processes. The only thing this is saying that you can put a @ sign in front of a process and then you make a name out of it. Like, you're not binding anything here.
Okay, and you could bind another, any other process to that name.
Yes, yeah, true. And also, like, just note that this P, it can be anything, right? It can be any combination of these.
Yeah.
Yeah. Yeah, that's a very good one. Yeah. But it's indeed, but binding and unbinding, I don't think we'll cover it really in this tutorial. But you're not binding anything here, actually. Only here, you're binding X in the process P. Okay.
So it strikes me that to define what a process is, this isn't quite complete. I mean, 1 plus 1 is a process, and the word hello in quotes is a process. So
yes, yeah, it's true. That's completely true. And also, new X in is also a process, right? But these are the foundational. This is, as I said, this is not Rholang, but this is the row calculus, and Rholang is derived from the row calculus, but this, as you could say, is kind of extension. But the row calculus is like really the basics. So that's also why I wouldn't like to stick too deep here, because it's not Rholang, which is the topic of this office hours, but it is the basics of Rholang. So that's why I thought it's a good idea to start.
thank you.
And you can find this, by the way, in the architecture document. This.
Yeah,
Yes,
and
like-
one more comment I would make about this row calculus description, at least my understanding of it is this row calculus is to Rholang what the lambda calculus is to functional programming languages. Is that a good analogy to keep in my mind?
Yes, as far as I am concerned, that is indeed completely true.
And
The only
ours
difference
differs.
being
And
that
ours
if you-
differs.
The only difference, I think, is that if you're writing like a normal coding in a normal language, like you don't really get to know what is happening on the lambda level. But Rholang is actually very simple, similar to the row calculus.
You're right. Ordinarily, when programming in a functional language, you don't pay that much attention to the lambda calculus, but you just kind of know it's back there and was what the language was based on.
Yeah.
But I think you're right. We do live a little closer to the row calculus than functional programmers live to the lambda calculus.
Yeah, yeah, that's true. And maybe in the future that will change. Like you don't necessarily have to write Rholang to interact with a tuple space. You can, well, if maybe PowerFX wants to develop another language, they in principle can do that. But it's very beautiful, I think, that we stay so close to the actual calculus. Okay, so if there's no questions, then I'll continue. So we do the send, right? That's the first topic. We still have send and receive. Send, well, it is like sending on a name. And as an example, we can do here new my first name in. So this is like a construct. Basically, here you're creating a name, and then we use the bang operator, just as in the calculus, to send on that. And I can do that actually. I can write here. Oh well, before I do it, maybe somebody else can just explain me what they think is going to happen here.
From what I can see here, you're creating a new channel called My First Name, and you will send them the process or the string hello world to the channel My First Name.
Yeah. And something more, that's it? Will be printing something on channel? Will there be a printing or something?
Yeah, it's going to print going to print out hello world.
So what I do here, indeed what you said, I'm creating a name by the new operator. Then on line 2, I send something on this channel, which is by the exclamation mark, and if you correctly said, I'm sending a string. I say hello world.
Can you make that bigger?
Yeah, the screen
Yeah,
is too small.
yeah, that's good.
Better.
Yeah, so what you said, indeed, I'm creating a name by doing new and then the name of this name. And then on line 2, I'm sending on this name and I'm sending a process and I call this process hello world. So a string is a process. That's string. An integer is also a process, but the process can also be can be like sending, receiving.
What of
These are all
bowling? What of
processes.
bowling? What of bowling is true or false? What of bowling is like true or false? Are they also processes?
Yeah, a boolean. More examples of what can be a process.
You can have a new process
Yeah, a
or do nothing
new
process. And nil, I meant nil, like do nothing.
Yeah. So these are all example of pro. So this list is not exhaustive. Like there are many more, but processes. As you see already in Rholang, we have many more types of processes than what is defined in a row calculus. Up, I comment them out. Otherwise, I get a syntax error, and then I run it. And I'm not sure if I can increase this. Maybe with up, very big. So here you see it being evaluated. So here you see I'm creating. Well, I don't know what these are, but anyways, here. So this kind of
Are you
abstraction,
sure
right?
that
Hmm?
I was saying, are you sure this is what has been evaluated? Because what it's showing us here is we created three channels
Yeah.
earlier while wrapping the first channel inside the earlier.
I don't know what they are, but I think this is the only program I wrote. This might be something of Archain.cloud or something of.
Yeah, I think it's from somewhere because you can show that there are 3 channels. Why you wrote only 1 channel?
Yeah, very good question. I have no idea, but anyways, you see that these are not being used. As indeed here, I'm also only using one, and this is the actual program. So X3 is like my first channel, and then here I'm sending on X3. I'm sending hello world, but these are like the low-level implementations of Arch Cloud. But what's important is that there's no output, so nothing is actually getting printed. So actually, the only thing is happening here is I'm creating a send on a channel, but that's it, right? There's nothing interesting happening, just as here, send on a name. Okay, that's it. So nothing interesting yet. It gets more interesting when we are doing a receive. So receive is like listening on a name, and when received, do something. So this do something was not there in the send, so that's why it was not so interesting on its own. So here I'm just starting with the same. I'm creating a name, and this thingy here, which if you're new to Rholang, might be very interesting because you might think it's a loop, but it's not a loop. We call it the for comprehension. And what this one is saying is say listen on my second name, so on the channel my second name. This is the wildcard. It means whatever we get, we don't care. But anyways, get something that's fine. And then do something. And this do something is like a process, right? We can have a process. That's really abstractly what is listening in Rholang.
Okay, I think that my understanding of a new receive is that if you use an if you have a new receive, it means that there won't be a com event happening on my second channel or my second name if you're doing a send on my second name. For example, what I'm saying is if the process inside of this for comprehension is a send on my second name,
Yeah.
then we won't have a com event.
Nick, that's correct. And why do you think that's not? We don't have a com event there.
Yeah, because we have a new. We're telling my second name to listen, but we're not telling it to listen for a message. We just want it to listen for nothing.
Okay. I'll put it in Arch in the Club because it's interesting what you're saying, and maybe we can get to an answer together. So here I'm just copying whatever I wrote there. I say new my second name in so that means this second name is available between this brackets, double space, double space, double space, and you're saying that okay, if we do that, so we are listening on my second name, and when we get a message on my second name, we want to print on my second name, but this one is not happening, right?
Yeah.
Okay, so maybe somebody else can give me a cue on why this will not be happening, why there's no com event. And for those who are new, we'll talk about com events in the next slide, so this is already kind of a sneak preview.
I think for it to happen, the for and the send has to happen concurrently. That means there has to be a part that separates them.
Yes.
But in this case, it's received something before it prints out, but it's not receiving anything. So there's no part separating it from receiving something. That's why it won't actually evaluate. It won't.
Yeah. So indeed, the for is like the for comprehension. Can you see it now? Should I make it bigger? For comprehension, it is listen on a channel and when received something, when received, then do something. And here we're indeed listening on the channel, and when we receive, then we are sending on this channel. But the funny thing is that here we're actually never sending on this channel. Well, we are sending here, but we are only sending when we are receiving something. But we're never receiving something, so we can never send something. See, that's a kind of deadlock. So that's why I can run it. Oh well, illegal character. My second name. Why is this illegal character?
Is that the kind of quote you're supposed to use? I didn't think that's a quote. Yeah. Okay.
Oh yeah, why is that? I don't even know how to make the other quotes actually.
Yeah. At first, when I saw it, I was thinking that was how your computer writes.
Yeah.
Double quotes.
Yeah. So indeed, here again, like we are seeing, there's nothing is happening actually. There's no more print on it, but well, don't stare too much on this output because it's kind of cryptic. But I just tell you, there's no send happening. Like line 4 never happens because we never receive something here. Maybe a nice follow-up to go directly to the next slide, which is about com events. And you don't necessarily have to explain it now, but maybe tell me how I can make a com event happening here. So how can I inform this one? And let's just for clarity make it because we don't want to end into an infinite loop, right? So this is a process. This is a quota process. So this together will be a name. So this is valid syntax. How can I print something? How can I send the message print on the channel at test? On the channel test. How is it possible? How can I do that?
You use a par to separate it and you receive on the channel at test.
Mm. Yeah,
then,
so
you now do a for. Yeah, you do a for comprehension that receive a white flag at the name at test.
So you're saying I should put another for comprehension here. Maybe somebody else has another suggestion. Really good. but I'm actually looking for something else.
Yeah,
Or maybe I didn't understand you correctly. Also possible.
I think what he wanted to do was receive on the test channel, but what we want to do is send on the my second name outside that for comprehension in a parallel process.
Yeah. Okay, that's true. So we have seen how we can make a send, right? That is here. If we do a send, we take the name and then we put the bang, and then we do the send. So indeed here I'm like receiving here, but there's nothing to receive yet. So I have to send something and do it by second name and then bang. And then here I just, well, let's say again, hello, do you hear me? Let's send this, right? And if we do this now, well, again, oh yeah, indeed. Now here we see on the output that we are sending on test print, but well, don't look too much on this output because it's confusing. But anyways, here a com event happened.
I think we should use CryptoFX to test it. The output from CryptoFX is usually more stable than that from our chain cloud.
Okay, well, we can do that next time. I haven't looked too much into CryptoFax yet.
Oh, okay.
But I will look into that. That's a good suggestion. So that was kind of sneak preview. Now let's explain what actually happened there. So I talked about a COM event, and a COM is like communication, right? So a COM always consists of a send and a receive, which happens concurrently. And concurrently, if you remember from the slide where I introduced the syntax, is described by this bar, which means, well, how should I say that? Concurrently, like this. So this bar means happens concurrently. So here I should actually put this bar. And also important when they happen on the same channel. So in previous example, when it didn't work, there was a send and receive happening on the same channel, but they didn't happen concurrently. Actually, the one never happened. And as an example of that, here's some code. So I create a new name. I call it my third name. And then just as before, I'm sending on my third name, I say hello world. And here I put the bar. Normally you would put it here. And here's this for comprehension, so that's listening. And I'm indeed listening on the same name. They happen concurrently by the bar. And then we do something. And then notice the bar, and also notice message, that I put message here. So in previous example, you saw me putting this underscore, but now I put here message. So maybe somebody already knows what this means. Putting this message there.
So we want the hello world message to be received on my name, on my third name.
Yeah. Yeah, true. So indeed, when you would do this, then the only thing I can do is like do something. And the fact that I send hello world, like it doesn't matter, because this underscore means whatever you receive there, just throw it away. The only thing what matters to me is that I'm receiving something, right? And by putting here message, I actually say, well, I care about what I'm receiving here, because in this continuation, I want to do something with the message. And well, that's what it means. I just call whatever I receive. So hello world in this case will be the message. And then if further on I refer to message, I will actually mean hello rules. So that's important to realize, I think.
Okay.
Okay, so maybe I can do the next coding example, but if somebody feels confident, I'm also more than willing to give my screen sharing to somebody else in order to send the message hello world on a name and concurrently listen on his name and then print the message to the terminal. So this is new. So this we haven't done yet, but I'm sure somebody in this call knows how to do this.
I think I could give that a try.
All right, I'll stop my screen. So please go ahead. Crypto effect.
Okay, yeah.
So to send the message hello world on a name, listen on this name, and then print to the message to the terminal. So what are you doing there? Just because I haven't explained it yet. It's completely good, of course, but
Yeah, you said I didn't get that.
yeah. What about print? Can you explain it to people in the call? What you say with print row IO?
Okay, so what I was actually doing, is this clear enough? I didn't know how to increase the size of crypto effects. Preferences should work with that. Font size. Okay. Okay, so what I was actually doing here is, this is like, okay, I don't know if the exact name is called, I think a command, an interface command, or a Rholang. Okay, I forgot what the actual word is called, but what this kind of commands do, whenever you see this row, then a colon IO, it's to have it brings a kind of powerful effect to whatever name you want to attach it to. For example, if you want to register, okay, that's outside the scope for today. You want to put a name within the name registry. You use the row IO, then the row registry, and the arbitrary command. So row IO standard out is actually used to print to screen. That is, whenever you attach this, whatever the command inside the bracket to a name, it means you want whatever is sent on that name to be printed to the screen. So that's a function of the row IO standard out.
Yeah, great. We'll see later what exactly it does, but that's a great explanation, I think. Go ahead.
Is that thing inside the parentheses and the tick marks, is that called a URI?
Yes, it is. And it binds the name print to that URI. And this is a row IO standard out. So that becomes bound to the standard out of the output of the RChain node.
Yeah, so you're on this line 2, you're doing two things concurrently. One, you're sending indeed on the name test, and you're sending the process hello world. and then you do the bar, which means do the things concurrently, do them at the same time, and then you listen on channel test, call whatever you receive message, and you're printing something. Is that correct?
Yeah, so let me run that and see if there are any errors.
It's supposed to work. Yep.
Okay, so there we have it.
Yeah, indeed. So this is not very pretty yet. Like you're seeing, actually, you must have some experience actually in understanding that this is a print, right? But as we know, this is what we call print, and all the other things is evaluating, and that's just happening in tuple space. But indeed, now you are printing. Yeah, great.
Okay.
Thank you so much. Let me take the screen again. Up. Share screen, please. Yes, there we are. So I did the same. I did new hello world. Well, you called it print. I called it std out. Like I'm just free. I free to call this whatever. Like the most important thing is that I'm defining a name, and then this is important because this defines that it's printing. And then here I should also do it like this. So I call it std out. You can also print it, call it print whatever you like. Well, this is the same as you did. So I'm printing a message, hello world, finally. Here I'm listening. I call whatever I receive message, and then I'm sending to std out. You are sending to print. I'm sending message. Okay, yeah. So one funky thing, right? You did it very well. You put this asterisk in front of message. David, why did you do that?
Okay, like we saw earlier, to quote a name from, or to dereference a name into a process, we use the asterisk, while to quote a process to a name, we use the at.
Yeah, that's correct. Why wouldn't I just do this? Like I'm not allowed, or why do we? Well, okay, this is a name. I get
Free
that.
name variable is not allowed.
Yeah, who said that? Say it again, please.
Oh, sorry. I was talking to myself. Okay, I said free name variable not allowed. That is error to true. We try that.
Yeah, so you'll get an error message, right? Okay, we don't want error messages. So just a note on the quoting. Sorry, on the asterisk and the quoting. It's just a rule in Rholang that you always send processes. So you're not allowed to send names, and you always receive names. So you never receive a process. And here you can see. Here you have you have a name, and you put this in front, and you get a process. You have a process, you put the at in front, and you get a name. So that's what's always happening. And then this is the kind of rule that you always have to send processes and receive names. You have to know that, and if you're new to Rholang, you'll very often get the error message, which you just told me. And there is that names and processes are inherently connected, like the processes tourism, business, and trade happening in Amsterdam. And in Amsterdam, the processes tourist, like it's just the same, but that's the same in Rholang. So you put the asterisk, that's get the underlying process of a name, unquoting, and if you put the at, it give me the name connected to the process, and that's quoting. So I think that's about as difficult as it gets for today. Is there any question on this slide?
I guess I have a comment. I mean, I still get confused, and I don't know when to use ats and stars. It's, it's messy. But what I try to think of it as is that we send processes on a name,
Yeah, we're sending a process on a name, correct?
And we receive on a name. I don't know.
Yeah. Well, that's indeed correct. As confusing as it might sound, indeed, you're sending a process on a name, and then on this name, you're receiving also a name. But that's true.
Yeah, and it's with getting the idea that a name and a channel are the same thing.
Oh yeah, sorry. A name and a channel is exactly the same. Yeah.
So
Yeah, and one thing I might say about this name and process being the same thing is the terminology, as I understand it, calling these things name came from one branch of the theory, and talking about it in terms of processes came from another branch of the theory, and so as we talk about the language, if we use the context where the name, referring to the name is more appropriate, then that's what we do. But other times, we have to talk in terms of processes. And now I'm getting confused again because I'm getting confused about names and channels.
Well, it's obvious that you don't send a channel on a name. You have to send something on a channel. You don't send a channel.
Well, you're sending a process on a channel or on a name, which is like exactly the same. Like, well, don't try to be confused too much about this, because a name and a channel is exactly the same. Like, there's no difference between that. Well, it's correct. This is like something which is evolving, and some parts of the theory it was referenced as a name, and some parts of the theory it was referenced as a channel, and then row calculus came along and they combined these two. But in row calculus, it's exactly the same. And Rholang as well.
Okay, you're doing a great job. Just forget everything I just said, because I was really confused when I was trying to say that.
Okay, no problem. I think it's really valuable for people to speak up, because that means, well, this is confusing, and I agree. So it's no problem. Please do speak up.
I think you're helping to clarify things. That's good.
Okay, thank you. Yeah, so a very small exercise. Or maybe somebody who doesn't see it right away, just look at it a bit and tell me what is wrong here.
The message isn't quoted.
Yeah, exactly. So as I just said, we send processes and receive names, and just write it down somewhere on your whiteboard or put it in your brain. Sending processes and receive names, and here, well, we're receiving a name, that's good, message, and then here we're sending the name. No, we have to send the process. So what's happening then? Let me try if I can zoom. Oh, no, that's not possible. Anyways, you get an error. Name variable message at 223 used in process context at 313. Don't mind the lines, because they're not correct, because I use different print screens. But anyways, message used in process context. So what this is saying is just you're not allowed to send messages. You're not allowed to send names. Sorry. You should always send the process. And then how we can fix that is just to put this thing here. Is there another way how I could fix this? There is.
Fix one.
Well, I tell you, this is if I take away this asterisk, I'll get an error, right? So this.
Yeah, you could make the for comprehension an at. So
yeah,
that way you get to.
Yes, correct. So indeed, I can either do this or I do that, and I'll go over it shortly. So indeed, as I said here we're receiving a name message, and well, on a name I can do the asterisk and then I make it a process. So I just tell add message is a process. What I can also do, I can make it like this. I do add message, and then I can send this message. So let me see if I have space. Add message is a name, and just add well, let's call it a string. So this is also a name on its whole, but if you take the asterisk away or the add away, then I have a process. So if that confuses you, that's no problem. But just for now, sometimes if you read code, you can see it like this, and sometimes you can see it like that. Under the hood, it means exactly the same. But as I said, if it confuses you, don't think too deep about it. And if this helps you in understanding, reading other people's code, then I'm more than happy. And maybe next time we can talk a bit more about this, if that's wanted.
So if when you have at message, you're receiving hello world on at message, what you're saying in essence is receive hello world on name of the channel message and the name of the process message. Sorry.
Yeah, indeed. Yeah.
Okay.
So yeah, true. Because normally, indeed, you're sending and receive names, but by putting this S sign in front of it, you're explicitly saying, well, whatever you receive this name, make it a process, right?
You receive it, hello world.
I didn't hear that.
Name.
Sorry, David, we didn't hear what you just said.
So,
Though I think that this would be less confused than the art. I mean, it's you can think of it in a more logical way than the other way. Though I use any of them, but the art message is much less confusing than the other one.
okay, well, I think it's a personal preference, whether you prefer to use this or whether you like it to do it in this way. Anyways, you can always in the body, like you can swap unlimitedly from message to process and back to message and process again. Like it's no problem. You can just swap whatever you prefer.
Rinka, could I ask a question?
Yeah, please.
When we were talking about names, we said we could create a new name. We said we could create a new name with the new command.
Yeah, here.
Yes.
That's what you
And
mean.
then notice down inside there where the 4 parentheses message.
Mm-hmm.
Is that also a way of creating a new name where when we listen?
Yeah. Okay. Yeah, that's a really interesting question. So let me just take up this. So indeed, here I can create name by saying my second name, and then here, indeed, I do this like, and then I here on my second name I can send quote message, right? That's allowed, and then let's make it a bit nicer.
I think you need an exclamation point.
IOSTD out. And here I'm just print, right? Let me see, is it correct? Yeah, I think it's correct. Yeah. So here it says, hello, do you hear me? But what you're saying, and that's indeed very interesting. you're saying, just as I'm creating a new name here, am I in fact creating also a name here, right? And yes, that's what you do, because indeed here you're receiving a name. Well, here you're quoting this to make it process, but what I can also do, I can send, just I can always send on a name or a channel, I can send something. And then just to make it nice, I want a com event to happen, so I can send for second message on, where do I have to listen?
On message.
On message.
Message, thank you very much. And then here I do again print. Yeah, received second message. Yeah, so you see, indeed. Thank you. That was a very good question. So I'm defining a new name here.
Yeah.
But
So,
this is also a way of defining a name. So I'll go really quickly over it, and
that always confused me, because I was always confused when you used that new. I knew you had to create a name at some point, but the thing in the for never seemed like it was created.
Mm.
But the for itself is a name creation.
Well, if you write something here, if you do this, then you're not creating anything. Like, you're not binding any names. But if you say this, then you're in fact binding second message inside this scope. Yeah. And I think since we're like.
So in essence,
please.
So in essence, trying to say that you could actually bind the name with a contract or a for. Instead of just using the new to declare all the names, you could just do it with a for or a contract.
Yeah. Yes. Exactly. Exactly. Yeah. There's different ways. Well, we call it binding. Like this is in fact like the whole new thing is a process on its own, and now it gets a bit more technical. But this whole new operator is a process on its own, and in this process you're binding my second name and print in between this scope. Just as in for, you're also binding your binding message in between this scope. And the binding, well, it is a kind of way of defining variables, just to stick closer to the normal programming jargon. I hope that clarifies up. Maybe just for the recording, I'll just really quickly wrap it up, and then I'll stick around a bit longer to answer any more questions which are left over. A note on persistent send and persistent receive. So normally when a com event happens, and I just really quickly go over it, next week we'll do more, both the send and the receive disappears. So like you're having a send, and once it's being received, then there's no send anymore. The only thing left is the continuation of the receive, like do something, right? Sometimes we want to send, and sometimes we want to send and keep on sending, or we want to receive and keep on receiving. I leave it up to you when we want that. But there are use cases when you really need persistent send or persistent receive. The syntax for that is, instead of a single asterisk, it will be a double. And instead of this one, I don't know how to call it. My native language is not English, as you might have guessed. But instead of this one, you put the equal signs, and then you have a persistent receive. I thought about a bit of homework. Feel free to do it. Like, it's not like normal homework, obviously, but just think about the use case, and we can start the next session with just hearing from you which use cases you came up, where you either want a persistent send, a persistent receive, or both. And in this hour, I think I covered most of the first two chapters on this. There's a great tutorial. I advise it to anybody. And just review it and see if you can learn something more from that. And if you have any questions, also take them to the next office hours, and I'll try to answer them as well. And I think that comes to the last slide, and really short in time. Next time, I think will not be a slide like this, but we just do it more ad hoc, what comes up.
Can we go back to the last example you had of the persistent send?
Sure. This one?
Yeah. Okay, so if you were to do a persistent send of hello world to the hello world channel,
Yeah.
and then do a persistent receive from the hello world channel, wouldn't that infinitely loop?
Yeah. Yeah, it would. And that's where the use case of Phlogiston, like the cost accounting, comes around the corner, because we need some way to stop this, right? We cannot persistently send and receive in a blockchain context.
Of the same channel, yeah.
Yeah.
All right.
Yeah. Yeah, so as I said, any more questions, also feedback, really welcome.
Yeah, I was going to suggest toward the end something that you actually picked up, and that was, if possible, use a cursor to when you're talking, and try to, because it helps us to follow along with what you're talking about, to see the cursor move along as you're talking. And I find it helps me, you know, remember where I was, you know. And anyway.
Yeah, thanks. Next time, tell me directly. I hope it was useful.
Yeah, I found the whole session very useful, and I think it was well simplified, so anybody like could easily catch up and understand what is really going on, and I really like that about it. Yeah, thanks.
Okay, thanks a lot. See you next week then. Okay, no more questions?